SQS is going to be one of the most popular exam topic, and so you need to know it really, really well. In this section, I did my best to use diagrams because to me, to understand SQS, you need to have a visual cue. And so pay attention. SQS in the end is not that complicated once you're able to reason about it, but it is such a popular exam topic, so feel free to watch this lecture twice if that helps. So this is your SQS queue. And your SQS queue will basically take messages, and messages will be sent by producers. And so here's just a way of naming things. A producer can send messages to an SQS queue. It turns out that you can have as many producers as you want. You don't need only one producer. You can have 3 producers, 10 producers, 100,000 producers. Who cares, okay? Your producers will send messages to an SQS queue. On the other end, you're going to have a consumer, and the consumer will pull messages from the SQS queue. So remember the buying service and the shipping service. Well, your buying service was your producer, and your shipping service was your consumer. And so as well, you just don't have one consumer, you can have as many consumers as you want. And the number of consumers doesn't have to be the same as the number of producers. So you can scale those independently. Okay, so this is the idea of a queue. We've seen this in the past lecture. Producers send messages to a queue, consumers pull messages from a queue. Pretty easy, right? Now SQS, there is different kind of queues, and the first one is going to be the standard queue. It turns out that SQS is the oldest offering of AWS. It's over 10 years old, and it was the first thing to come out of AWS. It's that popular. So it's been running for a long time and very, very stable. It is fully managed, so you don't even have to set up a queue. We'll just go in the UI, create a queue, and we'll be done. It will scale from 1 message per second to 10,000 messages per second. It's really easy to scale SQS. You don't need to do anything. It's just built in for massive scale. There's a default retention of messages, which is 4 days. So your messages are short-lived inside of your queue. And the maximum retention for messages is 14 days. So once a message will be consumed, it'll be gone. So the idea is that you need to consume your messages within 4 days or a maximum of 14 days if you set that up. There's no limit to how many messages can be in the queue, so you can have a queue with 10 million messages, that'll be fine. Just be aware you need to process those within the retention limits. This is a really low latency service, so we're talking about less than 10 milliseconds on publish and receive, maybe a bit more sometimes, but very, very low latency. And there is horizontal scaling in terms of consumers, so this is what we've seen from the slide before. We're able to have as many consumers as we want, get messages from the queue, and we see the process a little bit later. You can have duplicate messages, so this is rare. This is usually when you operate at scale, but sometimes you will get, your producer sending twice the same message, and that's just by design. It's because it's super high throughput. So sometimes you can have duplicate messages, and it's something you need to know. And you can have out of order messages. So there's best effort ordering that happens, but sometimes your SQS queue will deliver your messages to your consumers in a different order than when it was received. And so that's just by design. So this is just something to know, because the exam will ask you about these things. Finally, there is a limitation. You can't send huge messages to standard queue. You can just send up to 256 kilobytes of data, which in my opinion is fine, but don't start sending a little bit of like videos or messages through SQS. That is not the use case, okay? You send data, you send small messages such as JSON. Now this is just for the standard queue, and there's gonna be a bit of complexity coming in. There's a delay queue. So the delay queue is that you can delay messages, and so the consumers don't see them immediately, and you can delay messages up to 15 minutes. So by default for the standard queue, it is 0 seconds. That means that when the producer sends a message to your queue, the message is available right away for the consumer. But so we can set a default at the queue level, or we can override the default using the delay seconds parameter when we send data to SQS. And so the idea is that we'll get the queue, the producer will send a message, and if we say, for example, 5 minutes of delay, then the message will be in SQS for 5 minutes waiting. And then after 5 minutes, the consumer will be able to see that message. So in case you need to delay some messages that don't need to be readable right away, this is a great use case. Now, in terms of producing messages, what do they look like? Well, we have to define the body. And as you can say, the body is 256 kilobytes maximum, and it has to be a string. So it could be whatever you want in that string, but that's your body. And then you can add message attributes or metadata. And so message attributes are key value pair. So you have a name, a value, and a type. Very simple. And this is optional for you to provide. And we also have seen before from the slide that we can provide a delayed delivery. And that's also an optional thing. Then the message is sent to SQS, okay? And then what we get back from SQS is a message identifier, so an ID, and an MD5 hash of the body, just if you wanted to store that for any reason. So this is what we get from SQS. This is a very simple messaging model, a body of whatever you want, and attributes of a few. And then finally, when we consume messages, well, the consumers, they don't get the messages pushed straight to them. They pull SQS for messaging. So the consumers will ask SQS, hey, do you have any message for me? And SQS will respond, yeah. And maybe I'll say, I have 10 messages for you, or I have 0 messages for you. So your consumers can only receive up to 10 messages at a time, okay? SQS will not send 1,000 messages to your consumers. And so your consumers have a duty to process the message or messages that they receive within something called the visibility timeout. And then once they're done with the message and the visibility timeout, they can delete the message using the message ID that was received and something called the receipt handle. So let's have a look. We have our SQS queue, and the messages are being pulled by the consumer and then processed by the consumer. And so when your consumer has processed the message, then it will tell SQS, you can delete the message now, and the message is gone. So that's the whole process to consume messages. As you can see, the messages get deleted after they are being processed by the consumer. And so processed, what does that mean? Well, for example, if you want to say process a buying service, well, for example, the consumer will probably insert that message into a shipping database, and the message will live its life there. So the SQS is just here to transport data from the producers to the consumers, and that's it. So that's, the little scheme. Now, visibility timeout. That's one of the most important options that we need to know about, especially at the exam. So when a consumer pulls a message from the last diagram, the message will basically be invisible to other consumers for a defined period. So think about 10 consumers consuming messages from my SQS queue, and they all get messages from the queue. So the messages, once it's pulled from the queue into one of the consumer, it is invisible to the other consumers for a period of visibility timeout. And so you can set the visibility timeout to be between 0 seconds and 12 hours. So you still have a lot of choices and range. And so by default, it is 30 seconds. So if it's set too high, for example, if we set the visibility timeout to be 15 minutes, why not? And the consumers fails to process the message. For whatever reason, the database is out of order, the message is wrong, whatever the reason may be, maybe we fail to process that message. Then we need to wait 15 minutes before processing the message again. Maybe a same consumer, maybe another consumer, but that message will be invisible for 15 minutes. And that could be a big problem, for example, if you want that message to be processed as fast as possible. So if you set that visibility timeout to be something too high and your consumers fails right away, then you need to wait a long time. Now, if you set it too low, for example, 30 seconds, and the consumer needs time to process the message, for example, it needs to perform something for 2 minutes, then another consumer will receive that message because it's going to be available after 30 seconds and it wasn't deleted by the consumer fast enough. And so the message will be processed more than once and, possibly 3 times, 4 times. So you don't want to set it too high and you don't want to set it too low based on your use case. So how do you set it? Well, you know what you're going to do with these messages, so you think about a good timeout. Now, if your consumer receives a message and figures out, you know what, I think I need a little bit more time to process that message, you can change the timeout using the Change Message Visibility API. And so that's a very common API to know at the exam. Finally, when you're done with a message, we've seen this before, there's the Delete Message API to tell SQS that the message was successfully processed. Okay, visibility timeout, we got it. Now let's talk about dead letter queues. So we had standard queues, delay queues, now we have dead letter queues. So if your consumer fails to process a message within the visibility timeout, we've seen that the message goes straight back to the queue and other consumers can get it. And so if that happens too many times, basically because that message is not really good or no one can parse it or process it, and it goes back to the queue over and over and over again, we can define a threshold, and it's called a redrive policy. And so after this threshold is exceeded, the message clearly has something wrong with it, we can put it into a dead letter queue. And so we have to create the dead letter queue, and then we designated when we create our queue. We'll see this in the hands-on. And so we need to make sure that the messages in the daily queue are processed before they expire. But so the idea is that we have the dead letter queue right here, and our consumer gets the message, and it fails to process it, so it goes into a failure loop, and the message goes straight back into the SQS queue. That's one time. Then the message is consumed again by the same consumer, another consumer, who knows, and it goes straight back into the queue, second time of failure. Third time of failure, so the consumer gets back the message again and it goes back into the SQS queue. And so we've been 3 times doing the same loop, and maybe we set the redrafted policy to be 3 times. And so at the end, the SQS queue says, okay, that message looks like, it's a poison pill. It's not a good message. So we'll put this into a dead letter queue and move on. And so the dead letter queue will contain all these messages that really are problematic. And you can look at it and debug as you wish. Now let's talk about long polling. Very popular question of the exam. So when a consumer requests a message from the queue, it says, hey, do you have any messages for me? Now the queue can respond right away and say yes or no. But you can also wait for messages to arrive if there are none in the queue. So you say to the queue, hey, are there any messages? And by the way, if there are no messages, I'm willing to wait 20 seconds until you have one. So this is called long polling. And long polling is amazing because it will decrease the number of API calls that you make to SQS, and you increase the efficiency and latency of your application, because as soon as a message is available, it will be sent to your consumer. So the wait time can be configured between 1 second to 20 seconds, and 20 seconds is preferable. And so all the documentation suggests that usually long polling is preferable to short polling, and 20 seconds is preferable to 1 second. Now, long polling can be enabled at the queue level, as a default, or you can, when you do consume, use the wait time seconds API. So let's have a look. The SQS queue is here, and our consumer pulls a message from the SQS queue, but it says, hey, I'm willing to wait 20 seconds. So this is long polling. Now, it turns out that there's no messages in my SQS queue, so my consumer is going to wait. But turns out a producer just produces a message right now. And so that message will be passed on to my consumer who's been waiting for maybe 5 or 10 seconds, and my consumer will get that message right away. So here what happens is that I just saved a ton of cost because I waited and I didn't ask SQS every 30 milliseconds, do you have any messages? So to put it all together, and to me, if you understand this diagram, you've understood SQS, and if not, look in the hands-on, comes back to this lecture. But so here's what it looks like. We have our SQS queue, and we have our consumers, and they do long polling. Just ask for messages and wait maybe 20 seconds for these messages to arrive. Now we have producers, and they can send many messages, could be different producers. And so when these messages arrive in SQS, they will be passed on to my consumer. When my consumer is done processing these messages, it will use the delete message API to delete it from the queue. And then other consumers may consume other messages. And if the message isn't processed in time, within the visibility timeout, it'll go straight back to the SQS queue. And if that happens way too many times for the same message, then that message can be put into a dead letter queue or DL queue. So if you look at this, you can see all the parameters you have for your SQS, long polling, visibility timeout, all these kind of things. Even delay messages, you can set it at the producer level. And so that's SQS in one diagram. So we've learned a lot right now. Let's go ahead and practice this.